The concept for EPARTRADE is basically, in my opinion, there's a big hole in the internet. So the internet started many years ago, but there's never been an online business community for racers on the World Wide Web. The need for EPARTRADE is actually quite obvious. Basically, people in the business of auto racing need a place online to hang out and get their problems solved.
It's extremely simple for a buyer or for a supplier to interact on the platform. The first thing you need to do is sign in, which is free. And the second thing is, when you see a product that you're interested in, all you need to do is click on request more information. If it's a company, you click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
You can go to epartrade.com, you become part of a community of businesses in racing, and it makes sourcing products much easier than just on the internet or using Google.
At EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier through an email.
More than that, it's a place to go just to keep current every day. So it's a good place to start your workday in your racing business or in your offices of your professional race team. And you know you're current when it comes to new technology, industry news, technical papers, technical videos, all of that and more. We're not looking for a million hits per day. All we want is people who are really the volume buyers of racing products in the racing industry to be part of the little world of EPARTRADE. We have racing businesses participating from around the world. So you get suppliers from around the world, you get buyers from around the world.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Good morning from California, and welcome to Race Industry Now, the technical and business webinar series from EPARTRADE, presented to you by ARP and Performance Plus Global Logistics. I am Francisque Savignan, the founder and CEO of EPARTRADE, the global platform for the performance and racing industry. This is episode 220, and we are going to be talking to Ben Strader from EFI University. So it's going to be fascinating. With me this morning are Judy Kin, the co-founder of EPARTRADE, and our wonderful host, Brad Gilly. Judy?
Well, thank you. And actually, I'm in the Midwest right now. Came out last week for Bill Simpson's life celebration. So it was really nice to see him. He passed. We lost him about 2 years ago. So it was a nice, warm, loving celebration that we had at the IMS Museum. And I'm staying out here this week and going to hit the Indy 500 race. So if anybody's in town, you're welcome to reach out. We'd love to meet up with you at the racetrack. So it's going to be a good presentation today with University EFI, and we're going to hand it off to you, Brad Gilly.
Well, thank you very much, Judy, and thank you, Francis. Really appreciate that, and very much looking forward to this one. I'll tell you what, it just seems like every week, every single race industry now that we have, there's something great and something new, and looking forward to talking about EFI University and our topic today, modern racing engine development and tuning with EFI. And joining us, of course, from EFI University is Ben Strader. And Ben, welcome. How you doing today?
Hey, I'm doing good, Brad. How about you, man? How's it going over there?
Fantastic. I know we got to chat a little bit yesterday, which was fun. And before I get too deep into it, I just want to make sure I'm pronouncing your last name right. Is it Strader or Strader?
Strader is how we say it around these parts.
Okay, good enough. We'll make sure we get it right the whole way.
All good.
We have a lot to talk about, which is going to be fantastic. And as always, want to let you know, if you want to dive in anytime and you have a question, you are more than welcome to ask that question in the chat. And we've got a lot of different topics that we're going to be covering here over the next 45 minutes or so. And it's going to be a lot of fun. So first of all, Ben, let's just talk about EFI University and what you guys are doing out there in Lake Havasu, Arizona.
Sure thing. Well, I didn't start here in Lake Havasu. I started over in Southern California. Actually, I had a small business building racing engines back in 2003 when I started this company. And the way that it really started originally was just sort of weekend seminars. And the first one that I ever did was June 24th, I believe. Maybe it was the 23rd, 24th of 2003. I did that down in Dallas, Texas. And I just thought that I was doing a weekend seminar. I didn't know that it was going to turn into a whole career. But immediately the demand started to grow as people found out what we were doing. And it's interesting because that turned into doing lots of seminars and traveling all over the world. And then eventually, like, we have to have our own facility. So somewhere around 2006 or 7 or so, we started with a shop over in Southern California. And then in the end of 2012, early 2013, we moved over here to Arizona. But effectively what it's turned into is, we've now taught our courses in 9 or 10 different countries. Tens upon tens of thousands of people have come through our courses. And we ended up here in Lake Havasu, Arizona, which is a great little resort town. So people love to come and visit. And our courses have just expanded over the years, and it's been great. But effectively, what we are is what I like to consider an a la carte trade or tech school that's mostly geared towards adults. We're not the traditional vocational school that, like, a young guy or girl might graduate from high school and then they need the next couple of years to go off and do semester after semester. We're really hyper focused in single subject material. So somebody could take a few days or a week off of their work. They come here, get intensely focused on that particular, whether that's EFI engine tuning or engine development or valve train development or whatever the subject material is. They can take what they learned and immediately go back to work and become profitable from that. And then typically they'll come back and visit us some other time for the next thing. So that's sort of the really short version of what we got going on out here.
Yeah, and one of the good things as well is when it comes to the in-person and classroom experience, really class size is fairly limited. So you're not lost in a big room amongst a bunch of people. You're actually right there involved with everyone, right?
That's correct. I've gone to great lengths over the years to develop and refine the communication side of our program. And I've learned that when the class sizes get really big, then the individual kind of question and answer and the attention that each student gets goes down. And I've done it where, I've traveled to other countries and you're only there for a few days. So we do this big, huge, speaking emporium type seminar. And I've had 40, 50, 55 people in one seminar. And while that's great from a revenue standpoint from the business, I don't think it's great from a long-term standpoint of building relationships with people that want to come back and learn if they don't have a really positive experience. And so over the years, we've sort of figured that out and narrowed it down. And, the demand is still high. So we continue to add more courses, but rather than just put more chairs in the classroom, we just do more courses when that needs to happen.
Well, let's talk about the courses that you guys offer. And I know some of the ones coming up, you even have just some limited availability if someone wants to jump in, which would be a great thing. But first of all, the in-person instruction, and maybe we can even get into some of the online as well.
Sure thing. So we've had a lot of different in-person, like hands-on courses over the years. And right now we've narrowed it down to just a couple. Probably our biggest seller, our most important class is what we call the ACP, or the Accelerated Certification Program. And I'll give you a little background there. It's a basically how to tune racing engines using electronic fuel injection. But it's a really, really in-depth look. It's not your typical, like, guys want to know, how do I pick the air fuel ratio, or how do I use XYZ brand, right? A lot of guys show up thinking that they want you to tell them what number to put in this particular brand of ECU so my car goes, right? It's not really that kind of course. It's much more of a thought-provoking kind of instructor-led journey starting in the classroom, and we go to the very fundamentals of engines, back to 8th grade auto shop, right? Like 4-stroke engine cycle. And because what I've found is there tends to be a big language barrier. Engine guys, car guys, sort of enthusiasts, we inherently automatically speak this like vernacular with buzzwords and sort of we have our own acronyms and stuff that we just kind of assume everybody knows. And I'll tell you quickly a funny story about that, of how I learned to communicate that differently. Was my daughter is really, really interested in racing and engine development. And her name's Allie. She's 14 now. She's been coming to the shop and working on engines with me since she was probably 8 or so, when she started in the NHRA Junior Drag Racing Series. So one day behind me, I don't know if you can see really well, we have a machine called a Spintron there. But it's an electric motor and it lets us spin the engine and test valve train stuff. But anyway, one day she was over here and it was just her and I working. And I said something like, okay, are you ready? We're about to turn this engine 10,000 RPMs, right? And she goes, what's RPM? And I go, oh, it's revolutions per minute. And her eyeballs got really big and she was almost like frightened. And I was like, is everything okay? And she sort of explained to me that she thought I meant the entire engine was going to turn 10,000 times. And I was like, oh, no. That means only the crankshaft inside the engine is going to turn. And so it was one of those things that I took a step back and I'm like, maybe we have to be careful about the words and the language that we use, because your computer that controls the engine is just like that. It takes everything you say literally. So when we started the ACP class, we start at the very beginning. Doesn't matter what level you come in. And we have guys that are engineers for professional level racing teams, and we have hobbyists and enthusiasts that all come sometimes in the same class. So it's really important that we start at the beginning and get the language right first. Then we look at all of the things inside the computer, the tables and the variables that you put in, the different sensors and how you scale them and calibrate them. Once we've learned how to make the engine do what we want with a computer, the next question becomes, great, what do I want? How do I know, why is a Hemi different than a wedge engine? Why is a 4-valve different than a 2-valve? And what sort of things change my opinion on what I need to give the engine? So now that I know how to do it using the tool, I got to know what I want to do. And so after we've finished all that stuff in the classroom, what I consider to be the most important part of the course is we leave the classroom and we go out into the shop and physically put our hands on it and do it. And so I always say Thursday is the least interesting day of the class for me as the instructor, because that's the day that I sort of turn them loose and let them go and practice. And I'm like, okay, well, while you're learning, I'm standing here watching you learn. So it's way less fun for me and way more fun for you. But it's really rewarding to see our students come and really change the way that they think about how engines and computer work, and then watch them actually go put into action and learn it. So, we define learning as a change in behavior that's based on experience. And so the example I like to use is when you're young and somebody says, hey, don't touch the stove, that's hot. Well, we all had to go touch the stove and figure it out. Now we don't do that anymore. We changed our behavior based on that experience. Well, learning can't happen without some sort of experience. And I feel like just sitting in the classroom or listening to a lecture or watching a video online does not give you the experience that getting in the car on the dyno and actually maneuvering and manipulating controls gives you. So once our students leave that EFI tuning course called ACP, or at the end of the course anyway, they've now taken specific training, they've gained knowledge, they've practiced and demonstrated proficiency in the real course of action in the field. And then we allow them to take a knowledge test where they can actually demonstrate to what they've retained. And so what happens is they leave here, maybe not being the world's leading expert on EFI engine tuning or whatever. However, they've demonstrated that they know what to do and that they can do it. So I call that, now you've earned your license to go learn, right? You go out in the field and you actually start getting better as you hone your skills. So that's the major class that we do. The other class that we do is a little bit different. It's called competition engine development. And it's really not an engine building class. It's not how to assemble and use the torque wrench and that kind of stuff. It's a little bit more deep and advanced. And we sort of assume that by the time you get here, you've already had some experience there. It's a much more in-depth look on gaining engine efficiency in terms of competition and racing engines. We look at materials, we look at tolerances and clearances required. We talk about a lot why in our type of work, in real racing and competition engine development, we don't typically use the term engine blueprinting. We feel like that's the wrong approach because blueprinting is a valuable thing, but it involves setting the tolerances and clearances and machining the engine to a specific set of guidance that somebody else developed. But if you're using different materials and you have a different goal and you have a different operating environment, those may not work for you. So we look at how you would go about designing and developing a competition engine based on the needs of the program. Is it power level? Is it reliability? Is it RPM range? And all of the aspects of doing that, starting with a clean sheet and determining, well, how do I know to reach the goal? What size should the engine be? What should the operating RPM be? How do I know I have the right amount of cylinder head availability? Is the port too big? Is it too small? Valve size to bore ratios, valve train development, camshaft picking, and so many other concepts. But those are the real, sorry for talking on and on forever. Those are the real kind of current classes that are the most popular that people come to at our facility right now.
Well, look, the philosophy is fantastic. You know, you teach someone how to think. And when you talk about the engine development side of things, you know, we come on here every week and it might be someone who's into drag racing. It might be someone who's into stock car racing, you know, off-road trucks, whatever it might be. And when we talk about different forms of engines, obviously what works over here might not necessarily work over there. What you need over here might not work over here. And sometimes it's real easy to look at the fancy new parts and everything, but that may have nothing to do with what you're doing in that. So just being able to teach someone to, hey, these are the parts and pieces you need to assemble over here, to be able to ask the question of, well, what are you looking for when you're building an engine, and then be able to answer them and giving them what they want.
Yeah, and I really like what you said there. Is my real goal is to teach people how to think, not what to think, right? I don't want you to leave here and build engines my way simply because I've got lots of trophies and we've had success. And funny enough, one of the very first things that I tell my students on the first day of all of our classes is, I dare you to spend all of your time here and don't believe anything I say, right? The truth doesn't require you to believe in it. So what I say doesn't have to be what you walk away doing simply because you think I'm some guru or master of engines. What I want to do is teach you how to develop a testing methodology where you can get your own answers. You don't have to ask everybody else for their opinions. You can get real data and let the engine tell you what it wants instead of letting everybody else tell you what to make your engine, you know, look like or sound like or do. And as you pointed out, what works in a drag race engine simply will not work in a circle track or a off-road truck or, you know, race boat or whatever else.
Yeah, I like that. We have a question from the chat, and I'm actually going to expand on it as well. But it says, can you brief us on your work for Reno Air Race aircraft engines? But beyond that, your credentials as well. You know, if people are learning from you at EFI University, who are they learning from?
Sure. Well, you know, one of the things I don't do a lot of in my classes is brag about myself a lot. So I don't know, maybe that's a character flaw or something. I should spend more time telling people how great it would be if they came here. But I've worked in nearly every venue in professional level motorsports, grassroots all the way through professional level. I've done consulting with NASCAR Cup teams. I worked in NHRA Pro Stock on about 6 or 7 different engine program teams there during their transition to EFI, as well as on the engine development side. I've done circle track racing, off-road racing in the Baja series in Baja California. I've done lots of marine stuff and even airplane stuff. So the story behind that is in 2006 or 7, I was giving a kind of a weekend seminar in Southern California, and a gentleman was attending the class. And every time I start a class, I ask everybody to introduce themselves. And so as we go around the room and, you know, everybody says, my name's so-and-so, and this is what I do. One of those guys stood up and he said, you know, my name's Daryl Greenemeyer and I've done some airplane racing. And he was real nonchalant about it. Sort of like, you know, oh yeah, and I race some airplanes. And he said, I'm really interested in this EFI thing, but if my crew chief that builds our engines and stuff knew that I was here, he would, you know, disown me because he's an old school guy and he likes the mechanical stuff. So I want to see if this will work for us. Well, anyway, turns out Daryl Greenemeyer was actually quite a famous Reno air racer. In fact, a lot of his aircraft today are in the Smithsonian Museum in Washington. So about a month later, I got an email from him saying like, all right, man, I reviewed all the material. I remember in the class you said this was supposed to be easy, and I just don't get it. Like, would you be interested in coming and helping our team develop this? And so that's how it started. In 2007, I met with them and we came up with a plan. They were at that time using Continental horizontally opposed air-cooled aircraft engine that was highly modified, twin turbocharged, and they had a scheme that ultimately didn't work out really well, but they had a scheme to drive the engine to higher RPMs to generate more power. The challenge to that in an aircraft, though, is that the propeller is typically directly mounted to the crankshaft. So when the engine speed goes up, so does the tip speed. The propeller is going faster and faster. And as the propeller blades exceed the speed of sound, then the efficiency goes down rapidly and dramatically. So what they did was connect a single speed gear reduction between the crankshaft and the propeller. That way we could spin the propeller at the correct speed and turn the engine up. So the engine was originally designed for a maximum speed of, I think, around 2,700 or maybe 2,750 RPM. Back then we were turning it 4,200, I believe. And so the engine at 4,200, and we had about 80 inches of mercury manifold pressure. That works out to, I don't know, a bunch of boost, basically. We were in the 1,200 horsepower range, and we went to Reno, and we ended up qualifying. I don't remember if we qualified number 1 or not, but we qualified very high. It's been a long time. We went 365 miles an hour with the airplane, which was a modified Lancer Legacy with this twin turbo IO 550. The interesting thing about it, though, is we did a lot of testing on the ground, taxiing at high speed up and down the runways at the Jackie Cochran Thermal Airport in Southern California. And we actually did experience a very minor failure early on in the testing. We did lots of ground runs and everything was great. And then the very first time we decided to try a test flight, he took off and he got about 300 feet in the air and the engine shut off. And so the only thing that was really fortunate was there was multiple runways at that airport. So he literally just turned and landed on the next available runway. But it was exciting there for a few minutes, until we got him safely back on the ground. And we ended up finding out that the problem was a temperature issue with the sensor that measured the camshaft position. It had it turns out a hard limit of 150 degrees Celsius, which we were not reaching on our short runs on the ground. But as soon as we got a long enough run in the air, we exceeded that temperature. And luckily, it's something we discovered quickly and remedied with a different type of sensor, and had lots of success when we then test flew the airplane and went to race it. Now, unfortunately, we never actually raced that year. We did qualify and made several laps, but the idea that they came up with the gearbox to reduce the propeller speed was using a Lenco transmission planetary gearbox. And unfortunately, there's nothing to dampen the input pulses from every time there's a cylinder firing. So 6-cylinder engine, every 120 degrees, you have a piston that's banging on the crankshaft, transferring that vibration directly into the gearbox. And so the little planetary gears kept failing. And, we sort of had a team meeting and said, all right, after the third one has failed now, this is one of those situations where it's probably better off, always the takeoff is optional, but the landing is mandatory. And so if we decide to take this thing off and have another failure in the air, that could be dangerous. And we just decided to forfeit and sit it out. But we still thought it was successful to have a EFI aircraft that went 365 miles an hour and qualified for the gold level, in the Reno Air Races. So yeah, it was cool. Hopefully that was interesting.
Yeah, that is really cool. Actually, that's a great story for sure, and a great question. And again, if you do have a question, feel free to type it into the chat, and we'll definitely talk about it. Well, let's talk about EFI versus carbureting and carburation rather. What's changed in modern engines between EFI versus the older carbureted engines?
Well, a lot. I think it's fair to point out first, though, that doggone those carburetors do a really good job of keeping engines running well. So I think the biggest change, though, is the ability to control more than just fuel delivery to the engine. A modern EFI system is really a complete vehicle management system. In the old days, it was you turn the injectors on and spray fuel, and then when they got really sophisticated, we can even control, the ignition coil. And then we got really sophisticated, and we could have 8 ignition coils, 1 for every cylinder, and then we could pulse the injectors relative to the firing order, and just sort of kept getting more and more advanced, so that we, instead of the old days where we have this one, let's say, for example, V8 engine, we have 8 cylinders all feeding out of our fuel delivery source. And so we're always playing with the carburetor, trying to put jets on this corner different than that corner, and, really trying to make the engine the best compromise we could arrive at. What's changed with the EFI now that we have complete control individually is that now we treat it like it's 8 one-cylinder engines, and each one can have its own ignition timing, its own fuel delivery. And more importantly, we can change the fuel delivery across the operating range of the engine. Whereas with the carburetor, we kind of accepted that it was going to be a little bit rich over here and a little bit lean over there, but the average was pretty good. We don't really have to accept that as being true anymore. So a great example of that is if you have a drag race vehicle or a circle track vehicle. When there's external forces on the vehicle, like high G loads, which cylinders get fed the most air and fuel can change quite easily. And so what cylinders get richer or leaner at the starting line for a drag race engine won't be the same as you get going down the track and the scoop gets filled with air and gets pressurized. So with the carburetor, we were always trying to find the best compromise. With the EFI system, we simply create a curve for delivery and scheduling of fuel delivery and ignition events that treat it like every cylinder is going to be the best that it can be at every RPM, as well as through the transients. Now, a lot of things happen to the engine when you rapidly change the engine speed. When we change gears, for example, and we sort of jerk the engine backwards, a really high performing vehicle, say like a NHRA Pro Stock car, will accelerate obviously much faster in low gear than it will in second or third or fourth or fifth. Well, it's not uncommon to see acceleration rates of 4,000 to 5,000 RPMs per second as the engine accelerates in a low gear. However, when you change gears, because that ratio tends to pull the engine backwards, we might see negative 15 or even 18,000 RPMs per second as it tries to pull the engine back down to the RPM for the next gear. Well, that means that in fractions of a second, the air and fuel demands for each individual cylinder are changing, and we can address that with EFI, whereas we really never could with a carburetor.
Yeah, that's interesting. One of the things you and I talked about yesterday, and this talks about obviously leveraging technology, improving performance, and all of that. But you referred to EFI University as an R&D facility as well.
Yep. So I really do consider us to be an R&D facility as a secondary form of what we do. Obviously, our primary goal is revenue through training and education, and so I consider us a vocational school first and foremost. However, I really feel like most of the time when there's not a class going on, I only teach in the classroom the things that I want to learn. And so in order for us to really stay on the cutting edge, we are constantly doing real research and development. And what I mean by that is I think a lot of people are, the term R&D is almost a misnomer, right? And we joke around here sort of tongue in cheek that R&D is, reach and dial, pick up the phone and say, hey, what do you think I should put in this thing, and get somebody's opinion. And that's okay, but truly doing research simply for the purpose of research, rather than trying to meet some goal for a race event or a weekend that needs to be met, literally saying we're just going to test this to find out what we can learn, means that we go into it with the attitude that failure is always an option, instead of, oh, we have no ability to get this wrong. So unfortunately, what happens to a lot of engine shops is they can't afford to take a chance on some unknown combination or some unknown part that maybe won't make the power they need it to make, or maybe won't last as long as they need it to last, because the goal is to finish the engine, get it in the customer's hands so we can get paid and pay the rent and, get everything going the way we need to. So the end of the story is that if you're not doing research, including all the risk of learning something the hard way, it's hard to push the envelope and to move the industry forward. And so we typically are teaching in the classroom things that very recently we learned ourselves through research and development. And some of that we do on our own, using budgets from revenue generated at the school. Some of that we do through partnerships with industry manufacturers that don't have the testing facilities and want to create parts and they would like them to get tested. So we do a lot of that. And then we have a revenue-based section where people can bring us projects and pay for our testing and evaluation and development for them. So for example, maybe a guy owns an engine shop and he has a pretty good formula, but he goes, I really want to try and push this to the next level. I just can't really use my customers as guinea pigs. So they can partner with us and we can help them with research that is less volatile and risky for them, using both our technology and our equipment and our experience from other projects. And so it becomes like sort of a really multifaceted way. And we do that with our valve train development program on the Spintron. We have an engine dyno, we have a hub dynamometer and 2 roller dynamometers, plus the flow bench and microscopes and all sorts of other nerdy kind of technical stuff that we get to use on a regular basis. So I really don't feel like we're a normal engine shop. We don't build engines for the purpose of selling them. We do have a couple of, I guess you would say, clients that we do engine supply for, where we're constantly doing engine testing and development, and then they do go out and actually race them in competition. And that's been really great for us as well. But truly, most of the testing we do is for the purpose of learning, which means sometimes you learn what not to do as well.
Yeah, it's interesting when you say that. I keep thinking of the quote about Thomas Edison. It took him only 1 try to learn how to make a light bulb, but it took him 2,000 tries to learn how to not make a light bulb.
That's exactly right. It's very important to know what to do in racing, but it's just as important to know what not to do.
Yeah, for sure. A couple of questions from the chat. Are you going to do any research in electric vehicle race industry in the future? Is EV in your future at all?
I'll be honest, I feel like it's somewhat inevitable. It's not something that I currently have a real passion for. And I don't mean that to sound derogatory. I'm not necessarily against EV stuff. It's just out of my experience realm and my wheelhouse. Now, maybe one of the other guys that works here will develop a passion for it and want to follow that. And I have no issues with that. But I've also been doing this 19 years now. And so in another 4 or 5 or 6 years, I'm going to be looking at what I do. You know, I want to go fly fishing or fly my airplane or something other than this. I got to retire at some point. So I guess the answer is I don't know what the future holds as far as EV and EFI University. I'm not going to say no, but it's not something that I'm driving towards right now because I personally don't have the same level of passion for that as I do with the internal combustion engine.
Yeah, I like that. This sort of goes to one of the things we're going to talk about too. But the question is, how do you incorporate all the new technologies coming out these days in tuning engines? And, you know, when you talk about your facility as well, you are fully equipped to accept any of those new technologies and do all of that.
Yeah, for sure. And I would say that a lot of the new technologies that are coming out are somewhat in partnership or being developed right here. We do a lot, as I mentioned, we do a lot of testing as collaborative stuff with manufacturers. So when you go to the trade shows or, you know, on EPARTRADE's website and you see new products being delivered and developed to the industry, a lot of times we're already involved in that behind the scenes well ahead of time. You know, you're well familiar with my buddy Lakespeed Jr. He and I have spent countless hours in front of the dynamometer cell testing lubrications and oils and, you know, all sorts of piston ring combinations that he's doing now. And, you know, so a lot of times the products that are being delivered that are sort of latest and greatest and high-tech stuff to the marketplace have already been under development or testing for sometimes more than a year ahead of time. And so we love to be involved in that and leverage that because it's not only content for our school, but it's value add to our clients that need development work. So we're always on top of that stuff.
Yeah, we're big fans of Lakespeed Jr. here for
Me
sure,
too.
and it's awesome. Let's take that a little bit further. The capabilities of EFI University that you have beyond training student and about EFI and engine development and all of that.
Well, you know, as I alluded to, we also have the other section of revenue that comes from, you know, outside work. We are extremely careful and selective about who we allow to become one of our customers. And I don't mean that to come off as being like sort of cocky or arrogant or anything like that, you know. But at the end of the day, if we're not careful and you let too many projects come in the door, they become a distraction to our real goal. So I try really hard to keep us focused on, we're a vocational technical school first, and then we do the research and development to support the curriculum at the school. And the time that's left over, we take on some of these projects. Like, for example, behind me now, we have what's called the Sorceress, Project Sorceress Pro Modified Engine. That is a pretty well-known and famous vehicle that's out there on the you know, sort of drag race windscreen, if you will. A lot of people follow and know that engine. That is a complete billet engine, billet block, billet cylinder heads, billet manifold. It's a 5.3-inch bore space variation of a big block Chevy. So instead of the cylinders being 4,840 spaced apart, these are big engines, and it's typically twin turbocharged. This thing runs about 75 to 76 PSI of boost, making upwards of about 5,000 horsepower. And I met these guys last year. We happened to be racing at the same event. They were struggling a little bit to make the car go all the way down the track and have the valve train survive. And so a good friend of mine was working on the team as a tuner, and we were just chatting back and forth. And, you know, at one point he said, if you have time, would you just come over and take a look and tell us what you think? And I said, yeah, I'll come by, you know, and that led to, sort of sharing ideas and building a relationship. And so Rod, the owner of the Sorceress, said, hey, what would it take? How could we get you to help us on this program? And so now we're 7 or 8 months into this project. We finally got the engine here. We had a custom mandrel made to replicate the crankshaft in the engine so we could run it on the Spintron. In the last few days, we've been measuring valve motion via the laser and immediately identified a lot of issues, have already solved a few of them. And today and the rest of the week, we'll be also using high-speed photography to capture the valve motion in eyesight rather than by laser. And then we've got partners with camshaft company, Competition Camshaft, that's got new lobe designs that they designed and made for us last week, actually, and will be sending us new lobes to try to solve some of the issues that we have, and they'll be doing that over the next couple of days. But I mean, there's a great example of real-time up to the minute research and development that we're doing. And it's a combination of learning and using our experience to give the engine what it wants. And that's going on right now. So that's not uncommon to have customers come with sort of specialized projects that need a little more than the sort of run of the mill, like take it to a shop and let them do their best to fix it. They need a little more deeper investigation, and they want more data. They want to take sort of the emotion and the opinion out and make a more data-driven decision about where to take their program. So we can facilitate that, whether that's dyno, whether that's pre or post-mortem analysis through like microscope details, whether that's development work on manifolds, cylinder heads, camshafts, or whether it's simply trying to straighten out the valve train at higher RPMs and get things to work. So again, lots of capabilities. And we do have that side of our business revenue, but I'm cautious about it because I want to make sure that we stay focused on our real task and have strong relationships that we're nurturing rather than neglecting, So I try really hard to make sure we pick and choose carefully.
Yeah, and that's amazing. I mean, that really is incredible and a really cool thing that you guys are doing. And it does speak volumes about how, if you're working on all of these things, just how current your curriculum is and being able to teach everybody. Another question from the chat, and this one really does fascinate me. It says, I heard that you have a Kistler in-cylinder pressure measurement system. What plans do you have for using that in testing engines? And first, explain exactly what that is.
All right, so what that is we have combustion sensors that we can drill and tap holes directly through the outside of the cylinder head into the combustion chamber. And then you can thread in this high pressure sensor that allows us to see the pressure that's being generated in the cylinder all throughout the cycle. So through the induction cycle where the pressure is low, through the compression, through the combustion, and then the exhaust. And so we actually are able to instrument an entire engine, one sensor in each of the 8 cylinders, and we can collect that combustion data in real time while the engine's running from all 8 cylinders. And so what happens is that then allows us to change not only the tune-up, because as I mentioned earlier, we have 8 one-cylinder engines really all happening at the same time. It allows us to tell for each cylinder individually, does it have the right mixture ratios? Is the ignition event being started at the right time based on the RPM range, rate of acceleration or deceleration? So we can really nail it down every time. But more importantly, it also tells us a lot about the design of our induction system, camshaft valve events, and exhaust systems as we look at what the pressures are doing at those various points in the cylinder. So that's what it does. As far as what we're doing with it, it's currently installed. There's an engine project we participated in called the Engine Performance Expo, where it was a collaborative effort that Lake Speed sort of headed up and drove to design and develop an engine that would represent a typical aftermarket performance and sort of race engine. So we did that with them last year. A lot of manufacturers and partners contributed with parts and services and machine work and assembly. And then they brought it here to our facility to sort of be the independent testing facility. So we did the EFI installation and the calibration to get it up to snuff. Then we converted it to a supercharged engine, ended up making this small block LSX type engine. I think it ended up making a little over 1,300 horsepower, which was cool. That was very impressive, but we all knew even then it wasn't as good as it could be. So the next evolution was to disassemble the engine and do what we call here reverse blueprinting. So instead of checking everything when you're putting it together, we're now rechecking it as we take it all apart. And it typically takes us between 20 and 40 hours of labor, of man hours, to measure and document all those pieces. And you end up with a 15 to 18 page paper document of every tolerance and measurement that we could get. Now we have a before and after. Well, once we did that and we knew everything was good, then we made the modifications to the cylinder heads. We went back in and started working on the tune-up, which is now an ongoing process of using the Kistler, and Plex tuning is what we use for the data collection side, to collect that data, interpret it, analyze it, and decide what changes to do. So this year, the same engine will get used, and we'll see what improvements we can make through this higher technology.
Wow, that's incredible.
They're really cool.
Yeah, that is cool. I like that. That's fascinating. How does dissolved and entrained air in the fuel affect the air-fuel ratio? Have you done any research in this area?
So there's a couple of guys out there that are doing a lot of research in there. I think one of the guys out there that I know of is Mike Colburn, and he has spent a whole lifetime chasing this. I'll be honest with you, I haven't got enough hard data in my possession to make a statement to blanket the whole thing and say it's always this or it's always that. I do believe that having air entrained in the fuel system has an effect on the engine's performance. What I'm unsure of is the level effect that has and whether or not we have sophisticated enough data measurement ability to resolutely guarantee one outcome over the other. So while I believe that there's something happening there, I am of the stance that we probably need more time and more research before we're writing white papers about it to guarantee an outcome. That's my stance on it. That's very politically correct, don't you think, Brad?
I think that was really good, actually. That was awesome. All right, this gets directly back to what we're talking about with the school, with EFI University as well.
Okay.
What kind of things could I learn joining the EFI 101 Delta Lambda group?
So let's talk about Delta Lambda for a minute. The Delta Lambda group is a fraternity that we started a little bit tongue-in-cheek about our facility here. What's called EFI University, but clearly we're more of a real business and not a true like four-year university. I thought that was really funny 20 years ago when I started it, but it's actually been somewhat problematic throughout the years as we grew and people thought we were actually, a true university. That said, one of the things I'm most proud about, Brad, is that it's very, very difficult for you to go out there and after 19 or 20 years to find someone that's had a real interaction as a customer with EFI University in person that's came here and actually understood who we are, that ever walked away and had a negative connotation. You just don't find people that said, I went there, I didn't learn nothing, I hated it. What you find the most of is because we focus so intently on keeping the class sizes small and the class durations short, the number one complaint that we have is I got to the end of the class and then I had to go home. I really wish that I could have stayed and done more, but life was calling. I had to go back to work. I got family, I got, responsibilities. I wish there was a way for me to just be there more. So about a year ago, I came up with the idea of giving people more intimate and more often access to what we're doing here. And so we started a fraternity, we called it, called the Brotherhood of BTUs. And the title was Delta Lambda, which is the Greek symbol for change and Lambda being air-fuel ratio. And so what it is it's a subscription-based membership where people could join and then have weekly interactions with us here. So just about once a week or so, we put up in a private location where only our fraternity members can get to. We put up training videos so they can continue learning in their education. And then almost every week on Wednesday nights, we get together as a group on a live Zoom and we discuss topics of all manners. Now, the thing that's important is this brotherhood includes people from all walks of the performance industry. We have current NASCAR engine builders, pro stock engine builders. We have guys that are doing forced induction, nitrous, cylinder head development people, all over. The spectrum is unbelievable. You have your kings of the industry in there. You have your John Cazzies and your Billy Godbolds and George Bryce from Star Racing. And again, not to sort of brag up the group or anything, but what it does is it gives a subscription member access to that caliber of individuals. The Lake Speed's in there all the time, so you get to hang out with the people that are the movers and shakers in the industry, but without all the pomp and circumstance of like going to a trade show and they're standing there signing autographs. It's real interaction on a regular basis. So you're generating and building relationships with the people rather than just like this celebrity profile where you see them at a show and maybe you get to shake their hands. We're getting together as a group every week with the goal of, it's not EFI University teaching everybody, it's the group has the end goal of raising the knowledge and experience level of everybody in the group. So it's extremely powerful. And then we record all those sessions because not everybody, and we have members all over the world, so not everybody can make it to the same Zoom at the same time. So we record them, and then you can go back and rewatch any of the Zooms that we've done anytime you want. So there's currently a training library available to the Delta Lambda members that's got, I don't know, maybe 25, 30 or more hours of video-based training, plus at least that much or more of recorded video and audio of the Zoom discussions, where it's one of those things where we always start out the Wednesday night conversation, which we'll be doing tonight. This week's topic is about valve springs and valve train. Perfect timing since we have one on the Spintron there. We always start out with the intent of, hey, it's going to be a 1 hour discussion and we're going to talk about this. And almost always an hour and a half or 2 hours later, the tentacles have spread into all these other amazing directions because of the knowledge and experience of the members sharing stuff that triggers another question and moves you off into another direction. And I'll tell you, from a personal standpoint, it's been the most powerful learning experience that I've had in all my years of racing, because it's one of the few places that people are actually sharing rather than guarding high level technical information. So, I mean, I'm a terrible sales guy, but if people want to know about that, you can go to our website at EFI101.com, look at the Delta Lambda tab for the Brotherhood, and decide if you want to join. But it is an unbelievable resource to have available.
That's really neat. You know, we talked about the in-person, the hands-on training, literally laptop in your hand, cars on the dyno, all of those things, but online training as well. What does EFIU offer?
So we do offer some online training, and we do that mostly because of market demand and less because of my belief in the well, I'm trying to use the right word here, the effectiveness of it, right? As I mentioned before, we have clients from all over the world, and there are some people that just physically are not going to be able to come all the way here and attend. And so we want to be able to give them value as well. So we offer various, short duration online courses, from introduction to EFI, more advanced level EFI concepts, turbocharging, but, advanced kind of stuff there. We do some manufacturer specific, like how to use this brand of ECU. So we do have a lot of product offerings for the guys that just can't get here. But I'm going to be perfectly honest with you, maybe at the expense of my own revenue stream, and tell you that there is no way on any level you can ever replace the value of hands-on in-person learning with any amount of video training. You think about, I want to learn to be a pilot, so I start playing around with things like Microsoft Flight Simulator or whatever else. But until you've buckled your seatbelt in a real airplane and take off and leave the ground, you're really not flying an airplane. And so no matter how many videos I make and create and give people about running a dyno or tuning an EFI system or degreeing in a camshaft, until you put your hands on it and do it, you can't have the real experience part of the educational process that we talked about earlier. It's learning is defined as a change in experience, a change in behavior that's based on experience. So while I think that there is always going to be a need for remote-based learning, that will never supersede the value in actually going out and accomplishing the task.
Yeah, I will say your website, the video content that's on there, from just the introductory video of, hey, here's what we do, and you talk about the online training, is top shelf production. It is really well done, very well done. So
I'll tell you, that makes me happy. It makes me proud. When we built a lot of those, we actually went over to Southern California and rented a professional video production studio and all the people required to run it. And so a lot of those training videos that are on there were actually very expensive for us to make, but we really were adamant about having good quality, not just from the content, but the delivery. Let's be honest, everybody gets bored when you watch a video and the sound quality is not good, or it's, it's grainy. And so it was important to us to give value to the customer so that it's visually and audibly sort of appealing when they're doing that.
Well, if there's a right way and a wrong way, you guys are far on the side of the right way. It really is quality. And it's incredible talking to you. We said yesterday that we're probably going to look down and realize that we could keep going on for a couple more hours, and would love to have you here again at some point, Ben. This was so much fun.
I would do that in a heartbeat. It's been really terrific. We could even get more involved on a single subject rather than broad spectrum and get down in the weeds on stuff. But boy, you make it easy. You're a great host and you make it easy to keep rolling. So I appreciate that.
No, thank you, Ben. We appreciate what you do. And if we didn't get to every question, we apologize for that. But again, we'll have to do this again, Francis.
Absolutely.
Thank you very much, Ben. It was a pleasure to have you. And so we have recorded this webinar. It will be posted later on the EPARTRADE platform, as well as our YouTube channel. We'll share it to a newsletter pretty soon as well. So thank you very, very much for being with us today. We will be back on June 8th. Next week is Memorial Week, so it's a week a little bit shorter, so we won't have a tech webinar, but we'll be back on June 8th. And we have a full lineup until pretty much the end of the year. So thank you very much for being with us today, and let's go racing. Bye-bye.
Thank you.
Registering on EPARTRADE is easy. Fill out your name, email, phone number, and create a secure password. Next, select your business type. Choose supplier if you're looking to display products or services and connect with buyers. Choose racing business if you're looking to find new parts and connect with suppliers. Choose race team if you own or are a member of a professional racing team. Begin typing your company name. We most likely already have your company in our database, which you can select from the drop-down. Then, enter your job title. Choose Claim Company if you'll be editing your company profile. Other members of your company can choose Join Company if they'd like to use EPARTRADE as well. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Click Register Now, and your registration will be submitted for approval. You'll need to confirm your email once it goes through. To keep our platform industry only, you'll be approved shortly after. If we require additional proof of business, we'll reach out. Welcome to EPARTRADE.